My name's Colin Power from Into Infinity, and today we're going to be looking at the structure of number and the 8 infinities on the number line. What does that mean to have 8 infinities on the number line? Well, in order to work that one out, we're going to need some kind of calculator. You could use the calculator on your mobile phone or an online calculator, or even a very, very simple $1 calculator that you can just punch. It's not going to be any complicated mathematics. Okay, so let's start with the 0 here. Draw 1, draw 2, there, 1, there, 2. And 0 is the only one that has no polarity. And it forms a kind of boundary up its middle, like that. What we mean by that is we could take let's say we take a number, such as 2, yeah, we can multiply it, or any number, yeah? And we know that actually as we multiply that number, whatever number that is, it goes and gets bigger, yeah? So we could say this could be x squared, and it goes bigger and it creates something called infinity, and we call that out. But there's another type of infinity, which is through division. We could say, as we start to divide 2, it will start to go down, and down, and down, and down, and down. If we keep dividing by 2, keep dividing by 2, where will it go? A slightly smaller number, 0.5. And if I keep hitting the button, you can see it keeps going down, keeps going down, keeps going down. And we start to fall through a sequence of number. It gets smaller and smaller and smaller and smaller. So what we can see here is that as the number gets smaller, it starts to approach 0, but no matter what happens, we're never going to reach 0 itself. There's another boundary here, and this boundary here is the x divided. And you can divide by any number. You could divide by 3, you could divide by any infinite number, and it will create a unique pathway towards 0. Well, there's something in numbers as well as squaring. There's something called square roots. You get this number, which is the square root of 2. Now, this is called a power, and just as you can have, like, you know, to the power of 3, to the power of 4, to the power of 5, we can have to the root to the 3, yeah? And so we can start to see the reflection as the third root. I can change it to the 4th root. You can see it starts to get smaller and smaller. See here all these 9s and the square root of 2. So it starts to approach 1, but there's always a fraction left. It never quite goes over the 1. You know, if I change the number 2 to the number 3, for example, yeah, it still goes to be the same value, yeah? If you change it to number 6, yeah? I could put any decimal fraction in there, and it will always revolve down to 1. So it's nothing to do with that number. For every single infinite number, there's a curvature, if you like, by which that number will reduce towards the number 1. And so that creates a second type of infinite boundary. Let's say any infinite number here, we have a line going down there, and it goes down to 1, and that's to do with the square root of x, yeah, to the power of infinity, if you like, yeah. And if we did change this number to 0.5, yeah, this is a reciprocal value. It's between 0 and 1. And what you might think is it might go somewhere else, but it doesn't. Instead, it goes up to 1. So no matter what happens is, if you use a reciprocal number, then it's still going to diverge to 1. So that creates a second boundary, which is we start to draw here and start to draw there. It goes up to 1. Any reciprocal value, and that again is the infinite square root, yeah, of x. And so whether something's reciprocal or whole does make a difference when we're talking about these two spaces. But with these spaces, it just crosses the whole lot, yeah? And so square root values are very interesting because they show us there is another boundary here at the 1, yeah? Another boundary here. And oh yeah, we've got the infinite boundary out here. So there we have a boundary here, that's 1, another boundary here, 2, another boundary here, 3, and another boundary there, 4. That's 4 types of infinity. What you should expect is that with all this sort of numbers, that they should reflect, the mathematics should reflect equally onto the other side. As we said at the start, you start with a 0, and you know there's 1, 2, 3, 4, and there's a negative. Wherever there's a positive, there's a negative number. It always folds out in balance. There should be an arrow like that, and an arrow like that, yeah? And we should have a similar arrow for our squared numbers, getting bigger that way, and the other ones which are dividing numbers, so x divided or x squared, yeah, and that should send these things in those directions. But the problem is this here. is that once we start to multiply two negative numbers together, then really what happens is the numbers jump into the positive. Two negative numbers make a positive, and that's the current problem with the mathematic. So we don't see this balance within our current mathematical system because of that assumption that that's what happens. But in truth, you could say there's another way of looking at this, that we don't have to have two negative numbers when multiplied together suddenly equaling a positive. That's not actually necessary. So how can we get around all of that? Well, in order to solve that, what we're going to look at finally is something called 0 squared and the nature of number space itself. Here's our number line. I'm going to have a 0 in the middle, right? And let's say that's the boundary there of 1. That's 1 negative and that's 1 positive, right? And so what happens is that we can rotate this number line. We can rotate it like that, yeah, and create a second number line. And when we rotate it, what happens is this 0, suddenly you get another line coming out there and another line coming out that. So we call this 0 squared. Yeah, that's 0 squared. And it's quite a simple concept, that 0 squared rotates the number line. And now you've got two number lines, and this can be +1, this can be -1. And so if I multiplied +1 and +1, it creates, say, a dot there. Yeah, let's say it goes up like that, and it goes like that, doesn't it? Yeah, it creates a dot there. Yeah, and so when it creates that dot, you could say that's a plus dot. Yeah, and that's a positive negative space there. Yeah, now everything in there is a positive negative. We can do the same here. So that creates a dot up here. Yeah, but it's negative positive space. Yeah, so you can see that they're kind of reflecting like that, negative and negative. Yeah. And so what happens here now is that these spaces can represent any single number between 1 and 0 multiplied by any other number between 1 and 0, and this space here is the container, isn't it? Yeah, where things can start to happen. So rather than dealing with number lines now, we're dealing with number planes. And what we see is we're having 4 different types of number which now balance and we can now accommodate this, this problem here with this double negative jumping suddenly over here, and suddenly we can actually create a space for it in here. And that's quite important because in mathematics we're using the number I at the moment, and this is a different system. It's got the rotation of the number line concept built into it with 0 squared here. It's got the concept then of 4 ones that also have a kind of polarity associated with them. And what we notice then is that order matters. So if it's negative before positive, or if it's positive before negative, we'll also define where the dot appears. And so this is like a foundational structure of number, transforming it from the number line to the number plane. And if you look into our videos on the Russell paradox and various things like that, you can see how the concept of folding number space and this square concept of number space starts to have deeper relevance. So that's our structure of number and the 8 infinities on the number line there. 1, 2, 3, 4, 5 is there, and there's a boundary there and a boundary there. So 6, 7, and the final boundary 8. And 8 is a symbol that looks like this, and infinity is a symbol that looks like this, and when you put them together you get this. There are 8 infinities on the number line. So thank you very much everybody for tuning in for this episode on number, where we're solving infinity. If you would like to know more, follow us along by hitting the subscribe button to stay up to date with new videos coming your way.